Hello and welcome to this Carveco Maker tutorial. My name is Leighton and today I'm going to be showing you how you can import a 3D model, turn it into a relief in Carveco Maker and then machine it. We're also going to add a few little bits to it and machine it. So this is what I'm going to import, this car, and I'm going to personalize this by adding my friend's name on there and his birthday. So if I rotate this around, you can see that it's actually a relief. And this has already been machined. So let me show you what I'm going to be importing in this demonstration. So if I click here, you can see that I've taken a screenshot of the location that I got this 3D model from. And it's a well-known 3D model website, and it was free, which is what I like to hear. So what I've done, I've just downloaded this and then imported it into Carveco Maker. Okay, and I'll show you how you can do it. So let's close that. And I'll go to File and New. And I'm going to be doing this in inches. So let's do this 24 inches by 24 inches. The resolution, I'm just going to crank that right up to 2000 points. Now, this is quite important for any 3D work. If I were to have that right the way down to there, so it was 200 points, the resolution would be very bad. So it would give me very jagged edges on the 3D model and it wouldn't give me a good result. I always like to tell people it's a little bit like a television. It would be like literally zooming in on, say, an inch square of that television. And the result that you would see would be very pixelated. So what you need to do is make sure that it's anywhere over at least 1,500 pixels for this. Now, if you have a half decent computer, I would just crank that right up to the max to 2,000 pixels and wouldn't really worry about it too much. Now you can set the origin point on this white area here, so you can select any of the four corners or select the center. For this, I'll just use the bottom left. And as I mentioned, I'm going to be working in inches. Okay, so I'm just going to select OK and it will open a new model for me. So I'm not going to save the changes. And it places me within the 3D view, which is good because I need to be in that view in order to import a 3D model. If I'm not in the 3D view and I'm in the 2D view, you won't see anything. Okay, so just a word of warning, when you try to do this, if you are in the 2D view, it just will not work. So if I go to the 3D view, and what you probably want to do is rotate this around so you can see it better. So you can take an isometric view, so you can either do that by using this flyout menu here and select isometric view 1, or you could middle mouse button and just rotate it around the 0 plane. Okay, so let's import that model that I downloaded. So to do that, to import 3D models, what you need to do is go to the relief drop down and then select import, and then down at the bottom here you've got import 3D model. And here you can see this is the model that I downloaded. It's an OBJ file. Now Carveco Maker can import various 3D models. If you take a look under all supported files, you can see that it can import STLs, OBJs, IGES files, step files for instance. So you've got a lot of options there for importing. So this particular model is an OBJ model. So select open. This will load in the 3D model. Now, when you do load in a 3D model, you will get this dialog box, and it normally pops up in the middle of the screen. So what you need to do is to move that out of the way so you can see. So let's grab that and I'll move that to the top right. Now here you can see my car. You can also see this portion here. This is actually the zero plane that I created, which was 24 inches square. Now this model is actually 164 inches in X. So it's quite large. Now it's either been done pretty life size or quite large, or it's been done in millimeters. So what I'm going to do is first of all make it smaller. So let's make it, let's say 20. So it's going to be 20 inches. Now notice when I change the X size, it changes the Y and the Z size. That's because of these tick boxes here. Okay, and they're all linked together. So it scales everything in ratio to one another. So if I now select apply, that changes the size of the car. So what I can do now is zoom in. Now you can see that it's not in the correct orientation or position. So to get that quickly onto the top of the zero plane, what you do is select center, and it puts it in the center of the model and on top of the zero plane. Now this is actually how I want this particular model to be. I just want to move it down, but I'll show you how you can flip this around if you ever needed to flip a model around. So here you have rotate model about an axis. So you can do it about the X, the Y, or the Z. So let's say that I wanted to move this so it actually looked like a car that was laying flat. So what I can do is rotate this -45, select apply, and it starts rotating around. So let's do it another -45 and it should lay it flat. Okay, now you can see that that is above the zero plane. So if I select center, it will drop that down and place it in the center. So that's how you manipulate 3D objects. Now what I'm going to do with this, I'm going to paste this down now so you can see how 3D objects look within Carveco. Okay, what happens is Carveco cannot create any undercuts. Okay, so if I were to paste this down, anything that was undercut would just be brought down straight. That's not really a problem because it can only really do 3-axis machining. It can do 4-axis rotary, but the majority is 3-axis machining, so you wouldn't be able to machine that anyway because there's no 5 axes in here anyway. So let me just show you what it actually does. So a lot of this detail that we've got here will actually be lost. So if I leave that there, and I'll paste it down and I'll bring it back in a moment, because once you've done this you can't undo it. So if I paste that down, you can see that what it's done is it's brought everything down straight. So whenever it gets to an undercut, it will come down straight. So that looks a little bit weird. So that's just something to bear in mind when you're actually doing any importing of 3D objects. You need to sort of move it down until you sort of find the split line basically. So any undercuts, just bear in mind it will bring it down straight. Okay. Right, so if I want to reset this, go to reset relief and it will just get rid of this piece that I've just pasted down. Right, so let's do that again and I'll show you how you can import it. So it doesn't look like that, and I want a view from the side so I can do some engraving on there, and it looks like a sort of like a plaque. Okay, so if I go to relief and import 3D model again, select the OBJ and open. Now, as before, it came in, it's quite large. I'll resize it again to 20. Select apply, and I'm going to center that. Now what I can do is start lowering this down. So if I just rotate around so you can see. So what I'm going to do is make the car come down, because if I were to paste it now, these wheels would all have a flat coming down, and it would also be pretty high. So at the moment it's 8.5 inches high. So I'm going to bring this down. So let's try to bring it down. Let's try -8 inches and apply. So if I rotate that around, you can see that that's brought it down, but I've lost a lot of the detail. So I need to bring it up. Now this is an absolute measurement. So I can't now say I want to go, let's say, plus 0.5. It's an absolute measurement. So what I need to do is do -7.5. Okay, and that will bring it up by 0.5. So let's just keep on trying to bring that up, just so I get the detail from the roof of the car. So let's try 6 3/4. That doesn't look too bad. So what I'm going to do there is paste it down. Now don't worry about all of the car that's underneath there. This is just going to be chopped off. So if I were to paste this down now, and then select to close, you can see that it's chopped all of that off. And it's brought these wheels down straight, it's brought all of the car down straight. Now, if this is too high, at the moment, it's 1.75 inches high. And I don't really want to have it that high. Let's say I wanted this to be, let's say, an inch high. So what I can do is go over to here to scale relief. And when I select it, you can see that I've got this red arrow, and I've also got some options here. Now the red arrow just allows me to move it up or down, so I can in real time change the height of this, or I can enter a size. So let's say 1 inch and apply, and it will do it exactly 1 inch. Okay, and then I can select cancel, and it will bring me out of the tool. Now if you take a look down the bottom right here under model information, you'll see that the relief, the maximum Z, is 1 inch. So that gives you a representation of how high the model is. Okay, now something else that we're going to be using in a little while is if I hover the mouse over the model, if you take a look down the bottom right, you'll see X, Y and Z coordinates which move. So as I move the mouse, notice how the coordinates move. So this is a way that you can find where that mouse position is. More importantly, it gives you an indication of that Z height, which is going to be becoming useful later. Right, so let's machine this. I'll show you how you can machine this. So at its most basic, we're just going to bring this 3D model in and machine it. I'm going to do a few more things later, but let's just start off with the basics. Let's machine it. So go to Toolpaths, and then under 3D Toolpaths, there's Create Machine Relief Toolpath. So this is basically a toolpath that will use 2 tools. So you don't have to use 2 tools. it will use roughing, which is entirely up to you if you use it. I would suggest using it because what it will do, it will hog out all of the material where that tool can get in, rather than using the finishing tool, which normally is a rounded ball nose tool, which follows the contour, and that's what gives you that finish. So if I open up that toolpath, this is what you would normally use to machine a 3D relief. So for the time being, the area to machine, I'm going to do that over the whole of the relief. Finishing options, select there, and let me close my metric tools, open up inch tools, and for finishing, let's say a 1/4 inch ball nose. Now notice how this has got a rounded edge on there. Now you need to use something like this so it follows the contour and it will give you a nice finish. If you were to use an end mill to do this, it would give you a really, really bad finish and it wouldn't produce the desired effect. So click select, and then what I'm going to do is select a roughing tool. So select there, and I'm just going to use the largest one that I have in my database, which is a 1/2 inch end mill, and click select. Now I'm not going to change any of the parameters with these tools. I'll do all that in a moment. The safe Z that I've got here, this is where the tool retracts to. So when it needs to jump to the next move, this is where it comes to, and it's a safe point where it can move across the job, because if it doesn't go to this point, it could gouge right the way through the job and then probably break the tool. So let's set that to be 1 inch and also the home Z to be 1 inch. Click to define material. Now this is quite important, especially for 3D model machining. So define the material. The material thickness, let's just say for this example, we're going to say that this is 1 inch. The material Z0, this is all dependent on your CNC machine, whether it needs to be set to the top of the material or to the machine bed. So for this, I'll leave it at the top of the material. The model positioning material, I'll show you what that does in a second when we make the material thickness a little bit larger, and then I can explain to you what this actually means. So I'll just select OK for now. And if I rotate around, you can see that it's created this material block. So I'm just going to calculate this. It generates the roughing toolpath. So this is the 1/2 inch. This is going to blast all the material away. And then the finishing toolpath over the top, which generates all of the form. So let's close that. And you can see the toolpaths if I zoom in. So let's open up the toolpaths by selecting the arrow on the left there. Open up machine relief as well. And you'll see that I've got end mill, 1/2 inch roughing, a ball nose, 1/4 inch finishing. So if I turn off, let's say that light bulb, so click it, it will show you exactly where the end mill's going. Okay, so it's just roughing out all of this material. And then if I right click on the ball nose light bulb, it will turn the other one off and then just leave this one showing. And you can see that that's going over the top. Okay, so now let's adjust the finish on these. So let me show you first of all what this actually does. So let's simulate that toolpath. I'll do it with a control bar so you can see it. Okay, so that's blasting out a lot of the material ready for finishing. and it should leave whatever you specify in the toolpath. So let's just take a look. So the allowance is 0.02, so half a millimeter. Okay, so let's select the ball nose and let's simulate that. Now this one's going to take a little bit longer to do. Okay, so see how this is following the contour and going over the top rather than going around the outside of it. So let's fast forward that. And you can see it's starting to look like the car. Okay, so what I want to do now is show you how you can get a better finish. So you see here how we've got these lines. This is what we call the step over on, which is on the ball nose. So every time that it does one of those lines, it then steps over an amount and then comes back. Now, because it's a ball nose, it's always going to be to a point. So the smaller that this step over is, the better finish you will get. But also worth bearing in mind is the smaller that the step over is, the machining time is going to be longer. So it's a fine balance between if you want something to look really good and finished, or whether you want to create something quite fast. So if we delete the simulation, now what I'm going to do is just turn on the ball nose like so, and I'm just going to zoom in here just so you can see the difference. So you can see here, maybe on the door handle and around the tyre, you can see the distance between each path. If I were to double click on machine relief and then select the drop down for the ball nose, you can see that the step over is 0.03 inches. If I were to change that point to 0.005 inches, so 5 thou, and then calculate that, you'll notice that these lines become tighter. And this will give a much better finish, but also it's going to take a lot longer to machine. Okay, so let's turn off the roughing so you can see this. So here you can see the lines are really close together now. So this is going to give a much better finish. So if I were to simulate this now, I'll just leave this machine relief open, and I'm just going to right click and simulate the whole toolpath really quick, just so we can see what it looks like. Okay, so you can see that it's given me a much better finish now. So it's entirely up to you whether you'd like to have a rougher finish and produce it quicker, or have a better finish, less sanding maybe, for instance, afterwards, and it takes longer to machine. Okay, so another thing to bear in mind is when you do the roughing. So let me delete this simulation, and I'm going to turn on the roughing. Let me rotate this around and we'll take a look from the side. So if you take a look from the side, you can see that I've got two different toolpaths here. So these are two different depths. Okay, now that is controlled by the roughing options under the tool. So if I click there, I've got a step down of 1/2 inch. And I know that the material is 1 inch thick. So it's going to do 2 passes. So if I were to set that to, let's say, 1/4 inch and calculate, it will change it to 4 passes. Now, sometimes you may wish to do this, especially if you have a model where the ball nose can go into, and you don't want it to gouge down into the material. It might break the tool. So if I turn off that ball nose and we take a look at what this actually does. So if I simulate just the roughing, and you'll be able to see the areas that this gets into. So you can see that it's getting all around here and roughing it out. If I were to change that step down to what it was before, and I'll just change this step over just so it's a little bit faster, and click calculate. When I simulate this, you'll see that it won't have so many passes, but what this does, it means that the ball nose is going to have to do more work. So if I reset that simulation, and I'm just going to simulate that toolpath fast. So you can see that it's done 2 steps and it hasn't got into the areas where the 0.25 steps was going to. So just something to bear in mind if you want to save wear on the finishing tool. Okay, so what you will probably have noticed is that this is machining the whole of the model, the whole of the relief, and it's wasting a lot of time. Okay, so I'm machining all this area here. It's wasting loads and loads of time. So I'll show you how you can get around that. There are 2 ways. One way is to, when you open up the machine relief, you can do an automatic boundary. And what happens here is that Carveco Maker will automatically find the boundary of the model and then machine it. I don't normally like to use that way because it can take a little bit longer than the method that I'm going to show you how to do. So what I'm going to do is turn off the light bulbs, and I'm going to go to the vector drop down and then select create, and then down the bottom there you've got something called relief boundary. Now what this does, it creates a boundary around a relief, and you can just set this up to be at a specific height if you wanted to. For this particular job, I don't need it to be a specific height, I just need it to create a boundary for me. So if I click there and then click to create boundary and then close that, and as I said before, it's turned off the vector visibility, so I can't see them. So if I click there, you can see that they're all shown. Now what I'm going to do is press shift on the keyboard and just deselect that outside. I'm just going to delete these inner portions. Okay, so if I select the outside, and what I'm going to do is just offset this. I'm not too fussed about the size of this. I'm just going to move it out, let's say like so. Now, the only reason that I'm doing this is just so the tool can get inside there, and also when I come to it later, I'm going to cut the part out. So this is going to stop it machining all around the flat area that we don't need it to machine. So if we go to machine relief again and edit it, and this time I'm going to use selected vectors. And it's basically, this is giving me a warning that when you see it, it won't actually come to this vector. The center of the tool will come to it, so it will gouge into the edges. Okay, so something to bear in mind. If you were actually doing a relief that you wanted to come to this edge, you have to bear in mind that this is actually the center of the tool that's going to come to this edge. Okay, so let's calculate this now. And this should be a lot faster, especially when we actually get onto the machine, and save a lot of time. So let's simulate this. You can see it's not going all over the relief layer, it's just doing that little bit. And then can simulate the finishing. Okay, so that looks okay. What I'm going to do now is explain the position of the model within the material that I said about earlier. So let's say, for instance, I want to cut this out. This model is 1 inch, but the material that I had was 1.25 inches. So let's delete the simulation, go back to the machine relief, and let's set up the model thickness. And I'm going to change the material thickness to be 1.25. Now you'll see here that it displays the model thickness, so it's 1 inch. Now when I do that and I enter 1.25, it's basically got an offset of 1/4 inch. Now at the moment this is on the bottom, so if I select OK, and then if I rotate this around, and then we take a look at this, let's say like so. So you can see here that what it's done, it's put the model at the top of the block and it's got 1/4 inch at the bottom. Now if I were to set that up the opposite way, so I move that down, what it will do, it will move the model to be at the bottom and it will have 0.25 on the top. So if I now take a side view of that, you can see that it's got that fresh air at the top, so it's got that 0.25 at the top, so it's going to machine all of that off the top and then machine the model. Now I don't really want it to do that, I want it to be the opposite way around, so I'm going to flip that and then have this to be at the top like so. Okay, now the reason that I've done that is because I want to cut the part out afterwards. So I can close that now. And what I'm going to do now is do a bit of personalisation for this. I'll show you how you can do that, even though this is actually a 3D model and it's not a flat surface. I'll show you how you can create a flat surface and do some etching on there. So let's take a plan view of this, or a view from the top. And I'm going to create some text. So go to the text tool and I'm going to click there and I'm going to type in Rod and then put his birthday like so. Now if you wanted to change any of this, change the text, just left click at the end of that 8 or the end of the text, select everything, and then you can just change the font that you'd like to use, change the size of it, and then just click create. Okay, so what I'm going to do with this is just move this somewhere so it's on the door. So now you can do that by moving it just with the mouse, or you can select the arrow keys like so. Okay, so that looks okay. So I know that I'm going to have some problems trying to engrave this because it's not a flat surface. So I'll show you the sort of problems that I'm going to get. Okay, so if I zoom out and then go to toolpaths, and then let's create a V-bit carving toolpath. Select rod, or select the text. Start depth, I'll do that at 0 for the time being. Select a carving tool, let's say a 90 degree. Click refresh, and that will tell you the maximum depth that this wants to go. So it wants to go 0.057 deep. I'm not going to use roughing tool. I'm just going to select calculate now. So you can see that it's created the toolpath there. Now, what this has also done is if I rotate around, it's put the toolpath at the top. So the toolpath is actually above the 3D model. So if I were to actually simulate this, it won't actually do anything. So if I simulate that, so there you can see I've got my car, and then I'm going to use the control bar to do this, so it's a little bit slower. You can see it's not machining anything, it's machining fresh air because that section has already been machined. So what I need to do is set up the start depth so it starts a bit deeper. So let's double click on there and let's turn on the vectors like so. And here you can see the start depth. So that's currently set up to be 0 inches. Now I could start guessing and just typing in maybe 0.1 inch, 0.2, 0.3, just so on. Just keep on doing that. Another thing that you can do is if I hover over, like I explained earlier, it will give me a rough size. So you can see here from the top of the text, it looks like it's about, if you take a look down the bottom right, the Z value is negative 0.13. And if I come over to the 9 there, you can see it's negative 0.22. So there's a little bit of a difference here. So let's take the middle. So let's say 0.15. So refresh that, calculate it, and what that's done, it's lowered it down by 0.15. So if I were to simulate this now, go to the simulation control bar again. Now this should cut in areas and not in other areas. It won't look very good, to be honest. Okay, so it doesn't look that bad, but you can see that it's quite shallow at the bottom here on the 2, and then it's going quite deep at the top. And then the opposite on the name here, so it's deep at the bottom and then shallow at the top. That's because the door is concaved, so there's not really much that you can do about that, not in Carveco Maker anyway. In a more advanced product, then you would be able to get around this. So for Carveco Maker, what you can do, a little tip, is to actually create a flat. So what I'm going to do is machine it flat. So if I go to delete the simulation, turn on the vectors, and I'll just turn off the toolpaths. Let's take a view from the top. So what I can do is create a rectangle, and then I'm just going to draw one anywhere, let's say around about there. Now, I don't really want this door handle section here, and I don't really want to create a massive amount of flat that's over here. So what I can do is create a rectangle again. Let's do one, let's say there. Now, I'm just eyeing this up. I'm not really doing this very accurately, to be completely honest with you. Let's say like so. And then what I'm going to do is trim these off. So if I go to the trim tool, which is located here, I'm going to trim that off. Now you'll notice that I get a pair of scissors, and when I hover over, they open up. So if I click there, now you also have the option to auto join. Now what this will do, it will automatically join all of the vectors together afterwards, which you would need to machine. I'm not going to turn that on. I'll show you how you can join it without having to do that. If you happen to forget, or maybe you have in the future a vector that's not joined and you need to join it together. Trim there and then trim there. Okay, so let's cancel that. Now here you can see I've got all these segments of vectors. Okay, so what I need to do is select them. Now you can spot whether a vector is closed or not, because when it's open and it isn't closed, it will have a start point which is green, and it will also have an end point which is red. So that's an easy way to spot whether a vector is closed or not. So I'll select there, and then what we're going to do is come down to here where you've got join vectors with a line, and if you click that in that flyout menu, you've got join vectors with coincident nodes. This basically just means that it's going to join the vectors up for us. So click there, and then you'll see the number of vectors now is 4. The number of vectors afterwards is 1. So what it's going to do is join 4 vectors into 1. So click join, and now its number of vectors now is 1. So if I close that, you can see that I've got this start point. So if I select it again, it's all one vector now. Okay, so that's how I need it for machining. Okay, so what I'm going to do is select that, and I'm going to start machining a flat on the door. So what we'll do is go to toolpaths and create an area clearance toolpath. Now for this one, it's pretty much the finished depth that's important. So if I hover over somewhere towards the end there, I can see that that's 0.165. Go towards the end there, 0.21. Okay, so let's say 0.2 to start with. Let's see what that does. And I'm going to add a tool. Let's use a 1/4 inch end mill. I'm going to do this offset. So the difference between offset and raster is raster will come across in X and step over in Y and back across in X. So if I show you, it'll be easier to understand. So if I do raster, select calculate, you can see that what it's doing, it's coming across in X, stepping over in Y, coming back across in X, stepping over in Y. Now, I only really use this for rectangular shapes. If you're doing anything that's non-rectangular or it's got some sort of curvature to it, I would probably use the offset. What this does, it offsets the vector and follows it around. So if I calculate that now, you can see it's just following this vector and going round and then stepping inwards or step outwards depending on what you select here. Okay, so let me close that. Might have to change this, so let's simulate the machine relief and let's simulate the area clear. Okay, so what that's done, it's added a flat to it. So now I know that that is 0.2. So if we go back to the VBit carving The start depth, we make that 0.2 and then calculate that. This should do it on top of that flat area and give us a perfect piece of engraving. So if we go to simulation control bar and play that, you can see that it's giving us a nice piece of engraving. Now, if I wanted this not to be so prominent, what we can do is just delete that simulation, re-simulate that, re-simulate that, double click the V bit, and then we can make that a little bit smaller. So this would make it less pronounced going into that part there. So if I play that now, you can see it's just touching on the top of it. So this is how you can control the V bit. So let's make it a little bit deeper. Let's say 0.19. And then I'll just simulate that again. It should go a bit deeper. Okay, now you could always do that particular thing on the machine and just literally lie about the depth and make it go a little bit deeper on your CNC machine. It's entirely up to you. Right, so that's created the text, which looks okay. All that I need to do now is to cut the part out. So if I turn the vectors back on, you'll see that the original vector that I used to offset to create the boundary is still there, so I can use this to cut the part out. So if I now go to toolpaths and then go to create profile toolpath, I'm going to go outside. It automatically knows that the finished depth is the depth of the material that I have. Select a tool, let's say this 1/4 inch end mill, click calculate now, and then I can simulate that as well. So let's just fast forward that. You can see that that's starting to cut this part out. Okay, so that's the finished part. Now, if you wanted to rearrange these so they were in some sort of order, what you can do is, obviously the profile needs to be last, but let's say the area clearance and the V-bit carving, I wanted to swap them. What you can do is select the area clearance. You can either select these up or down arrows, or you can just grab it and just move it above the V-bit carving. Right, so let's say that I wanted to send this to someone to rod, just to check on before I actually machined it. If I go to simulation and select here, delete waste material, and you can auto delete the waste material. What I tend to do is keep pick material. So if I keep the pick material and just click on the area that I want to keep, it would just remove everything else. So there's my finished car that I want to machine. If I wanted to, I could add a depth colour to that, or I could add a material. So let's say that I wanted this to be out of, let's say, light oak, and apply. So I could just add a material to that if I wanted to. Now, to finish up, what I need to do is send this to the machine. So if I go to toolpaths and then select save toolpaths, you can see that I've got all of my toolpaths on the right hand side. Now, if I had a tool changer, all that I would need to do is make sure that these tool numbers correspond to what's in the carousel, and then choose the correct machine file format and save it. Because I haven't got a tool changer, or maybe a lot of people haven't got tool changers, what you can do is either move them to the left hand side, do each one individually, or you can save toolpaths to separate files. If I select browse, you can see that I'm already in this folder that I want to save, and I've given it a name of rod. So I'll select open, and then probably the most important thing is the machine file format. So you got G-code arcs. So if I select there, you can see all of the what we call post processors available within all of the versions of Carveco. And you can see lots of well-known manufacturers in there. Your machine will probably be specified in there. If not, and it's an imported machine, it will probably run on G-code ARCs. So just check that. These are basically converters that convert the information from Carveco into a format that your CNC will understand. Okay, so let's select that, and I'll select save. Now if I open up that folder, you can see that I've got rod toolpath 1, toolpath 2, 3, 4, 5. Now I'm not really too sure what they are. So what I'm going to do is delete those, and I'm going to append the toolpath details to the file names. This should look a little bit different. So here you can see it's telling me what it's actually doing. It's a machine relief, and it's using a 1/2 inch end mill, and it's a rougher. Exactly the same for these, just so you know what they are. So if I double click on this one here, you can see that this is just coordinates and commands. This tells the machine what to do. So you need to take this file, put it onto your CNC, and it will machine this particular file. Now if you want to have a look at these, by default may not be associated with anything. So just right click and then select open with, and then just choose WordPad or anything like that, and it will just open it up. It's just text.